Welcome to Organic Mind Map. Now we focus on hydroxy alcohol. Okay, so we will focus on preparation and reaction. Let's look at the reaction preparation part, which is on the left hand side. Okay, so as we know previously that we have learned in our other chapters, okay, for alkene, okay, undergo hydrolysis, then we will get alcohol, okay, and then another one is we can use Grignard reagent to prepare alcohol. Then next one, we also can use nucleophilic substitution, haloalkane, to prepare alcohol as well. Okay, another one is we can use carbonyl, okay, aldehyde, or we can use carboxylic acid. Okay, now we will move on to another one, that is the reaction part. Okay, the reaction part, okay, just now we have from alkene becomes alcohol, and then we also can have from alcohol becomes alkene using concentrated sulfuric acid dehydration. Okay, another one, we can react with, alcohol can react with metal, and because ONA is ONA, okay, so we cannot write the bond. Okay, it's actually positively charged and negatively charged. So it's an ionic bond. Okay, another one is esterification. That is carboxylic acid reacts with alcohol and it will eliminate one small water molecule. So this part comes from the carboxylic acid. Okay, another one just now we can see from haloalkane it can become alcohol, and again same thing, alcohol can become haloalkane again. Okay, if you want to use SOCl2 thionyl chloride, make sure you use pyridine. And remember, PBr5 doesn't exist. Okay, we can have PCl5 but not PBr5. Okay, now next one. Okay, oxidation part for alcohol. Okay, if you use PCC for primary alcohol, we will get aldehyde. If secondary, we will get ketone. Tertiary, there will be no reaction. Okay, another one is oxidation. Okay, if oxidation, we will get carboxylic acid for primary, secondary ketone, tertiary, no reaction. Okay, and then also, again, this is a iodoform test. Okay, if we have methyl group here, okay, one methyl group here, methyl alcohol, methyl carbinol, then we will get yellow precipitate. Okay, another one is using Lucas test. Okay, now let's look at others. Okay, which I will focus more on the oxidation and reduction. Okay, now we go to oxidation first. If we use KMNO4, if primary alcohol, it will become carboxylic acid. If we use PCC, it will stop at aldehyde only. Okay, but if let's say we use secondary alcohol, both by using PCC or KMNO4, we will still get ketone. And then for tertiary alcohol, no reaction. Okay, it cannot undergo oxidation. Okay, now reduction. Okay, for reduction part, if we have carboxylic acid, we will have primary alcohol. If we have aldehyde, it's the same thing again. We have primary alcohol, as you can see, it's only changes here. And then if we have ketone, we will have secondary alcohol. Tertiary, we don't have a tertiary one, okay? Now, let's look at phenol. Phenol is slightly acidic. Therefore, phenol can react with both base sodium hydroxide and also sodium metal. Okay, but if let's say we look at alcohol only, alcohol is not base, it's not acidic. Okay, thus it can only react with strong base metal like strong alkaline metal like sodium, but not NaOH. Okay, so remember it cannot react with sodium hydroxide because it's not acidic. Okay, now we move back to reaction of phenol. Okay, if we want to test whether it is phenol or not, we can use the bromine water, which we will get white precipitate. And also another one is the FeCl3, which we will get the purple complex. Okay, so that's all for alcohol, which we have phenol and alcohol part.